Good morning, Ingalls. Hey, I did the first lesson today and I forgot to share my screen. So now I'm going to try and do it all just with you guys. And hopefully I'll actually do this correctly so that you guys see my work as well. So today we're going to talk about 3.5, and 3.5 is on rational functions and what happens with their graphs. And so I am using a Zoom so because I would like you to go ahead. I'm going to share my Desmos activity. To me, I think it always helps to maybe look to see what the graph looks like, and it's easy to do that with Desmos. So today when we talk about rational functions, now remember when I say rational, we're talking about it looking a lot like just a fraction. So it's like a function. It looks like like a fraction. And so we want to remember all of those things that we talked about with the domain because they play in how that this is also graphed. So on this one, we had this problem probably in chapters 2, and it said, well, find the domain of the rational function. Well, we know that in the bottom of the fraction, it cannot equal 0. And so we need to factor this. And notice that x squared minus 64 will factor to x plus 8 times x minus 8. Well, in the top and the bottom, you'll notice that I still have an x plus 8 um, that cancels. So I'm left with then 1 over x minus 8. Well, I still have to remember from the get-go what my restrictions in my domain are. So remember, x cannot equal either 8 or negative 8, even though I canceled out the x plus 8. And so when I graph this, what happens is what's left right down below, when I have an x minus 8 that's left, that's going to say that x is going to get really, really close to to positive 8, but never actually hit it. And that's where we will discuss vertical asymptotes. So a vertical asymptote is where written as x equals some number, and it's also going to be connected to the restriction of the domain, and it's going to be a place where the graph will get close to it, but not actually ever touch it. So as the first little picture reads, it says that x approaches a from the positive direction. And so if a is going to be my vertical asymptote, if I look at the positive side, so that means it's going to be what is on the right, that the value of y just keeps getting bigger and bigger and bigger and never really touches that particular point. And then if you look as x approaches a on the negative side, in this case, this one's also getting larger and larger and larger, but never actually touching it. It can also go down to negative infinity. So sometimes you're going to have when x approaches a on this graph from the positive direction, it's going to go down to y is approaching negative infinity. And then the last one is going to be x approaches a from the negative direction is going to be then negative infinity as well. But when I graph this function, and I think that's what I'm going to do on the next page. No, we're not quite yet. So I want to just look at that one. I have that one in my Desmos activity. So if you click on that, you can also see I've got all of the graphs already typed in, and not that you can't type it in. But when I look at x plus 8 over x squared minus 64, notice that I still have that asymptote at 8. And as that value of 8 is getting closer and closer, see, if you look at the value of x, it's getting closer to 8. The value of y is getting larger and larger, and it just keeps going. But notice on this one too, I said that x cannot equal a negative 8. And so if I go ahead and try and scroll over here till I get to negative 8, we were able to cancel it, but notice right here, when it's negative 8, it's considered undefined. And so even though we cancel it out, it will leave what we call a hole in our graph. And so when I do the next problems, it says find the vertical asymptotes, if any, and then also of the graph of the rational functions. And so what you'll do on this one is what we want to find out is what values of x will allow it to be 0, make it 0 on the bottom of the fraction. So in this case, I know that my domain tells me that x cannot equal either 3 or, and in this case, because I pulled out that x by itself, it's also cannot, and this is where I'm going to struggle, it cannot equal 0 either. So That tells me that I have vertical asymptotes when, let me go vertical ASYM at when x is equal to 3 and when x is equal to 0. And so let me just show you real quick again. If I go back to my graph of my Desmos, I have that one listed. I'm going to go ahead and unselect the red and put this one here. And notice on this one, I have two vertical asymptotes. One is going to be at my y-axis, and the other one is going to be at the value of 1, 2, 3. Okay. Now, the next one is similar to the one we had in the front, but on this case, I'm going to go ahead and, again, x squared minus 25 factors to x plus 5 times x minus 5. And again, I'm going to go ahead and I can cancel the x minus 5s because they're exactly the same thing, and so I'm left with 1 over x plus 5. So it tells me that I'm going to have a vertical asymptote. I'm going to have a vertical asymptote. When x is going to equal -5, because I'm going to let this value underneath here be set the whole denominator equal to 0 and solve. So if when x plus 5 equals 0 and move the 5 over, x is going to equal -5. But I also have a hole where whatever canceled. So because of the x minus 5's canceled, if this value here was set equal to 0, then x is going to equal 5. So there's a hole at x equals 5. And again, I'll show you from Desmos how that looks. So I'm going to unselect this one and select this one. And so again, I have my vertical asymptote at -5. And notice here, as I scroll along here and I get really, really close to 5, it won't show, but it pops up there as undefined. And so when it does that, that indicates that there's a hole in my graph. And so what it's doing is it's getting really, really close to that value, but it's never going to quite get there. All right. We also have horizontal asymptotes that we will be dealing with today. And so our horizontal asymptotes, remember vertical asymptotes are where the denominator is undefined, but horizontal asymptotes are going to be what happens as the graph approaches some number y. And in this case, you can look at this graph is approaching this number, the y equals b. And so you would say as x approaches infinity, in other words, x is getting really big, y is actually getting closer and closer to this horizontal asymptote. It can also be from the top and coming down, and it can approach b. Horizontal asymptotes, you could actually have a graph cross that horizontal asymptote and then again go towards approaching it. But what we're really looking for is what happens on those extremes. As x is starting to get really, really big, or maybe x is getting really, really small, like going towards positive infinity or going to negative infinity, what value is the y getting closer and closer to? Well, in this case, there's a couple of rules that I want you to learn. And it's this one, the way they've written it, it looks a little more confusing it is, but they've got a polynomial on the top and a polynomial on the bottom, and these are just representing their leading coefficients. But really what I want to do is I want you to circle the m and the n because it doesn't matter on your graph as much on what's at the end of it. It really matters what the degree of your polynomial is. And so when I look at this one, when I look at n is going to be then the degree of my numerator. And sometimes I'll also say the top. The degree of the top. What is the degree of the top part of your fraction? If it is going to be less than the degree of your denominator, okay, or in other words, the degree of your bottom, then what would happen is that you'll always have a horizontal asymptote at y equals 0. So no matter what, no matter whatever follows it, it doesn't matter. You have to just start by looking at the degree. So what I'm going to do is over here on my first problem, I'm going to identify the degree of my numerator and identify the degree of my denominator. So the degree on the top is going to equal then 1 because I have x to the first power. On the bottom, I have a degree of 2 because I have an x squared. And so in this case, this is an example where the degree on my numerator is smaller than the degree on my denominator. And so I know that my horizontal asymptote is going to equal then y equals 0. Now, if you notice here, I don't have a vertical asymptote because if I try and go 3x squared plus 1 equal to 0 and solve to find out what values make the bottom 0, if I move the 1 over to the side, so I have and divide by 3, I have x squared is equal to a negative 1/3. But then I'm going to take the square root of both sides, and that's where I'm going to get then an I value. It's really like it's going to be like the I times the square root of 1/3, which I could simplify a little more, but I really don't really want to. I just know that there is not a real number that is associated with that. And that correlates really well with the graph that I look at. So let me go ahead and go back to here. Let me see, I've got the 15x squared plus 1, which is this one right here. Notice on this one, I have no restrictions on my domain, and that's why I'm not going to see a vertical asymptote. But I do see a horizontal asymptote, and notice as if I kind of squeeze this down a little bit so I get more values, if I get the value of 50, if I click on this, notice that I'm getting really, really small, but I'm never going to actually hit 0. And if I also go really, really negative on the negative direction, I'm going to go and get really, really small again, but never actually hit 0. So again, that shows that I have a horizontal asymptote on this graph at 0. Now my second one, I'm going to start off again. I'm going to do the same thing and look for the degree. So I'm going to have the degree of my numerator. My degree of my numerator is going to equal 2 because I have x squared. And the degree of my denominator is also going to be 2. And so when they are equal to each other, so back up to my rule, if the degree of your numerator is equal to the degree of your denominator, I didn't denominate degree of the denominator. Okay, degree at the top, degree at the bottom. I'm having struggles today. Then what I need to do is I really want to just go ahead and eliminate anything that follows my leading coefficient. Okay. And so I really want to think of in terms of going like 15x squared. I'm going to take out anything that's like the plus one. It's not going to matter. If I had even had an x plus one over there, it wouldn't matter. So then I'm going to make it a fraction of my leading coefficients. So I'm going to have 15 x squared over 3x squared. And then I'm going to start canceling out. And so 15 over 3 then is just going to be then 5. And so my horizontal asymptote is going to be then y equals 5. Now, I'm not sure how your algebra teacher did it before, but another way they've done it is by dividing everything by x squared. And by doing that, you would have the 15x squared divided by x squared all over the 3x squared over x squared plus 1 over x squared. And notice that this would be then getting closer and closer to 0. And so then they would go ahead and simplify, and that's how you're again going to go 15 over 3. So I'm not really sure which way your Algebra 2 teacher taught it, but I take it and I just go ahead and eliminate anything added and subtracted and take those leading coefficients and divide them. Okay, and let me show you this graph again. So if I go back to my equation, I'm looking for the x squared, this one, which is the 15x squared over 3x squared. And when I click on that, you can notice that it's again, I have no restrictions. I can get values everywhere. But as I'm approaching, as I get really big on my infinity, as x gets really big, then it looks like I'm getting close on my y to the value of 5. And if I were to even see if I can squeeze this down so I have more value. Oh, there it is, 150. At 150, I'm still getting close to 5, but I'm actually not hitting it. And the same thing goes if I go to the negative infinity. And look at this, as I go towards negative infinity, I'm getting quite a bit. I'm getting a very small number, but I'm also getting very close to 5 as well. So my next one is going to be what happens when the degree on the top is actually bigger than the degree on the bottom. And so notice that I would do the same thing. The degree of my numerator, NUM, is going to be greater than the degree of my denominator. Okay, and so in this case, my degree is going to equal 3. on the top because I have an x to the third. And then I have the degree on the bottom is going to equal 2. And notice since 3 is larger than 2, that means I have no horizontal asymptote. And in fact, I actually will have a slant asymptote, which we're going to talk about in just a little bit. But let me show you what this looks like. In this case, if I were to take this one and just select it, notice that in this case, I have this kind of like, it's not a line, it's like a kind of like almost like an x to the third equation here, but it's also looking like it's approaching some line that's going at a slant. Okay, and so this would be considered a slant asymptote. Let me show you some information before I go into it. What we'll be doing on our test is kind of trying to put all of this information together. And so we've got a strategy of 7 things that you will do on one of your problems that we have. So I've got a function of f of x equal to 4x squared over x squared minus 9. Now, in this case, if I want to start off, I want to think in terms of what kind of symmetry do I have? So in this one, f of x, if I replace f of negative x into my equation, I want to look and see what happens to my function. So I'm going to have a negative x squared. I'm going to have a negative x squared on the bottom, minus 9. And notice that both of these are going to be squared, and so the negatives are just going to be canceling out. So I'm left with 4x squared over x squared minus 9, which is exactly the same function that I started off with. Well, before that meant that I had then a y-axis symmetry. In other words, if you remember, we also called it even. So that means that I know that this graph will be have y-axis symmetry. And so I'm going to go ahead and underline or circle that because I'm going to use that in just a second. Now, I also could go ahead and find my y-intercept and my x-intercept. So to find my y-intercept, remember, I want to look for when x is equal to 0. So I'm going to look for f of 0. Well, when I substitute that back in, I'm going to have 4 times 0 squared divided by 0 minus 9. And so on the top, it really doesn't, I'm going to have 0 because 4 times 0, doesn't matter what I have on the bottom. But I have a minus 9, and I know that 0 divided by negative 9 is just going to be 0. That means I have the point 0, comma 0, and I'm going to just put that on my graph right there. That also would tell me that that's my x-intercept at this point. Could also check, and I would let my numerator so this would be my y-intercept. For my x-intercept, I would want to set my numerator equal to 0. Well, in this case, it's kind of a redundant point, so I'm going to say 4x squared is equal to 0, and then I know that x squared is going to equal 0, so x is going to equal 0. So I came up with that same point that I have, but that'll also tell me that I don't have any other x-intercepts. I only have this one at 0, comma 0. Now, the next thing I'm going to do is look for vertical asymptotes. Now, remember, vertical asymptotes are going to be when I look at the denominator and I look at the quotient. I'm saying what values here are restricted in my x. So if I have x squared minus 9, I know that I'm going to change that to x plus 3 times x minus 3. So on my vertical asymptotes, I'm going to set that I'm going to have one where x is going to equal negative 3 and x is going to equal a positive 3. So I'm going to go ahead and plot those in. 1, 2, 3. I'm going to put the line there. I'm going to go 1, 2, 3. I'm going to put another line there. Okay, and so I know that I have those as my vertical asymptotes. Plus I have this point 0, 0. Okay. Then I'm going to look for horizontal asymptotes. So on my horizontal asymptotes, I'm going to go ahead and look at my degrees. So the degree on my top is going to equal 2, but then on the degree on the bottom, is also equal to 2. And because they're equal, then I'm going to also look and I'm just going to I'm going to eliminate anything added or subtracted. And I'm going to go 4x squared over x squared and cancel out my x squared. So that means that I have a horizontal asymptote at y equals 4. So I'm going to come up 1, 2, 3, 4. I'm going to put a horizontal asymptote. Whoops, kind of got off my line just a little bit, but then I'll go ahead and draw it in my orange. Wow, I'm struggling on that one. Sorry about that, but all right. So I have found on my list, I've got my symmetry, I've got my x-intercepts, my horizontal asymptote, vertical asymptote, and my horizontal asymptote. The next thing I need to kind of know is, and they said to plot at least one point that goes beyond the x in the vertical asymptote. In other words, so this is going to be a vertical asymptote that's going to be at 3. So maybe I want to find out what happens maybe at 5. So if I want to find f of 5, and again, I could pick 6, I could pick 7, I could pick whatever I want. I'm just kind of going to try and go close to here because I want to find out, is my graph going to be up here in this section or is it going to be down here? And so when I do f of 5, if I go 4 times 5 squared all over 5 squared minus 9, then I'm going to end up with 5 squared, which is 25, times 4, which is 100, over 25 minus 9, which is going to be 16. And so I'm going to get a positive number, and I'm going to see if I can grab that. I think that's going to be about, not sure, 100. Let me clear this out. 100 divided by 16. Well, 6. It's going to be about 6. So that means I'm going to come up. It's going to be above my line of 4. So it's going to be in this area. Now I know because I have symmetry and I have my y-axis symmetry, that means that f of negative 5 is also going to be that same value. So I know that it's going to look a little bit like this. And that's enough for me for my graph. Now, the next thing I need to know is what's going to happen in these sections as well. I know that I have a point 0, comma 0, but what I ought to do is maybe find out what happens maybe at 1 or 2. And so I'm going to go ahead and try and find f of 1. If I have f of 1, that's super easy. So I'm going to go 4 times 1 all over 4 squared, or 1 squared, excuse me. Good Lord. 1 squared minus 9. So I actually have 4 over a negative 8. So that's going to be a negative 1/2. That means it tells me I'm going to come down. So I know that my graph is going to go, it's going to hit at 0, but then it's going to come down. Now remember, if I have axis of symmetry, y-axis symmetry, that means it's going to be the same for f of -1. So that means I'm going to come down, and that will give me enough for my graph for what I want. Okay, so you guys will have to do one of these on your test, but you'll do great. I know you will. But you'll need to go ahead and kind of work through all of those points. The last thing we're going to talk about is going to be slant asymptotes. And slant asymptotes are where the degrees on the top is larger than the degree on the bottom. So notice on this one's going to have a slant asymptote, and it's going to be when I have a degree, on this case, I have it of 2, and I have a degree of 1 on the bottom. And so because the top has a higher degree than the bottom, then I'm going to look for my slant asymptote. And what happens to be, it's going to be the equation y equals, and it's going to be this quotient. Now remember, quotient means the answer to a division problem, but it's also not going to include any of my remainder. So I just have to divide. So I can either do long division, and I will do a review on both. So I can do long division, and that means I'm going to have inside, I have x squared. Remember, I don't have an x term, so I'm going to go plus x and then minus plus 0x minus 4. But then I'm going to divide it by then just x. Okay, and if I do that, then x goes into x squared, just 1. It's going to be x here. I have an x here squared. I'm going to draw the line, change the sign, make it 0. Then I have plus 0x. So I'm going to have plus 0x, 0x, and Then I'm going to drop down my minus 4, and that's my remainder. So this one would be then minus 4 over x. Now, I'm going to eliminate any of my remainders, and I really don't need this 0x. It's just going to be, I should probably plus 0, not 0x, but I'm not going to even worry about this because it's 0. And so my quotient is just going to be y equals x. So my slant asymptote is going to be y equals x. Now, I could also use synthetic division. And we've talked about that one a couple of sections ago. And because of this is going to be x, it is not subtracted anything. I know that this would be the same thing as plus 0. So inside my box will be a 0. And then I'm going to go ahead and have then my leading coefficients. So it's going to start off with 1, then it goes to 0, and then negative 4. And so again, I'm going to drop down my 1. I'm going to put a 1. 0 times 1 is 0, 0, 0, and minus 4. So I get the same answer as I had before. So my reduced polynomial is going to be x plus 0 and then minus 4 over x. But again, this is going to tell me my quotient is just x. And so I'm going to have y equals x is going to be my slant asymptote. Okay. Um, when I graph that, I'm going to start off with graphing my slant asymptote. Notice here, if I start off with my original equation, I also have a vertical asymptote when this is going to equal then 0. So I have 1 at 0. And what happens is then if I pick a few points, it's going to approach both of those from both of their directions. And maybe I should put my asymptotes in orange. So it's going to approach these lines, but it's never going to quite touch them. And so I thought I'd go ahead and just show you real quickly what that kind of looks like on the graph for Desmos. And I'm going to show you if I have x squared minus 4, I'm going to go ahead and go plus 0. We actually did another problem here in a second, and I'm going to probably do that one. Let me eliminate those. Here's what my graph looks like as it's approaching now. Remember, I just told you that I have the equation y equals x. And so if I select that one too, notice that that's my slant asymptote, and that's also as the graph is approaching that. Now, some of the girls in the first hour or on my class here at Mineola, they said, well, how did I get the 0? And so what I did is I said, let me do example 2. But I'm going to change. I'm going to keep it really simple. I'm going to go f of x is equal to x squared minus 4 all over, and then I just had x plus 1. I wanted something that didn't I didn't have a whole. Okay, so again, I'm going to use my long division, or I could go ahead and use my synthetic division. This time, because I have a plus 1 in synthetic division, I'm going to go a minus 1. It's the opposite. And then I would have a 1, and then I'd have 0, and then a negative 4. And so then I'm going to just drop this down. I'm going to go 1. 1 times negative 1 is going to be negative 1. And then I'm going to have negative 1. Negative 1 times negative 1 is 1. And then I'm going to end up with 3. So my reduced polynomial will actually be then x minus 1 minus 3 over x plus 1 is my remainder. I'm going to get rid of my remainder, and I'm going to only use my quotient. So my slant asymptote would be y equals x minus 1. Okay, and so then I showed the girls what happened on my graph. So I came up here and I went ahead and went plus 1 here, showing that it does switch. I do now have I have a vertical asymptote at negative 1. And then if I put in my minus 1 here, I have then my slant asymptote that's going down. It also shifted a little bit too. So I hope that kind of makes sense. What I'm going to do though on slant asymptotes, I'm not going to ask you actually to graph it. I'm just going to go ahead and ask you to find a slant asymptote. And so it's not going to be as big of a problem, but I do want you to have an idea of what a slant asymptote is and how you can find it. But again, I'm going to do something similar to this. You can choose either long division or synthetic division. You don't have to show me both. But I'm going to ask you to pick one and then show me how you can find the slant asymptote. And then on these two examples, remember you'll have two, you'll have an equation that looks like y equals the quotient. Okay, hope it makes sense. Have a great day, guys. We will talk to you later. See if I can stop this recording.